In this section, we're going to talk about relations and functions. So, we're going to start with the basic definition of a function, and functions are used everywhere in science, in healthcare, in paying your bills, and the money you make. They're all considered functions. All right. So, a function is a relation that assigns to each element in the domain exactly one element in the range. So, what this is saying here is this, all right? We're going to relate this back to something that you and I both know, okay? Let's say, for example, I had a bunch of ordered pairs, like -3 comma -6, -2 comma -4, and 0 comma 0. All right, we're just going to use these three for now, okay? All of my x values, so -3, -2, and 0, these would all be called my domain. Okay. And then, give me 1 second here. Here we go. Then all the y values, -6, -4, and 0, they would be called my range. In other words, in math, we have a tendency to want to group things together. All right. So if I have all of the x values together, call them, and I'm going to draw like a little weird circle here. And if I put -3, -2, and 0 into this circle, that is called our domain set. A set is a collection of objects. All right. So that would be my domain. And then if I had, oh, wrong marker, my bad. Then if I had another weird looking circle, all right, and I started labeling -6, -4, and 0 within that circle, that is called the range. And the idea is that the relation or better yet, the function that says, hey, if you have -3 in your domain, that is going to go to -6. In other words, what we've done here is we've mapped them or we've related these two numbers together. -3 and -6 are related, just like -2 and -4 are related. And finally, 0 comma 0 are also related. All right. And that's what the function does. All right. Is it relates the domain and the range together. Okay. So the idea behind this now is, well, what makes a function so special? All right. And what makes it so special is right here. And I'm going to highlight. It's right there. In other words, what this is telling me here is this: if you give me a number in the domain, and I can map it or I can relate it to exactly one element in the range, I have what we call a function. And that way I can go ahead and start to predict things. Okay. So let's look at some examples on, like, well, how do we actually determine if something is a function or not? All right. So is the following a function? All right. So I'm going to just pull out some ordered pairs here, and I'm going to steal a couple of the ones that we used earlier. All right. So here's our set. It's going to be -3 comma -6, -2 comma -4, -1 comma -2, 0 comma 0, 1 comma 2, 2 comma 4, and 3 comma 6. All right. Now, in order for us to determine if this is a function, the first thing we're going to do is we're going to group our domain together. Now, remember, the domain is going to be all of the x values. So just scan from left to right: -3, -2, -1, 0, 1, 2, 3. All right. So -3, -2, -1, 0, 1, 2, and 3. All right. Now, the range are going to be all of the y values. So that's going to be -6, -4, -2, 0, 2, 4, and 6. And then the only thing I have to do is read my ordered pairs from left to right. So I'm going to start right here. I'm going to start right here at -3, -6. And all I'm going to do is draw a line from left to right. Okay? So -3 goes to -6. -2 goes to -4. -1 goes to -2. 0 goes to 0. 1 goes to 2. 2 goes to 4. And 3 goes to 6. And because every single element in my domain, all right, so I'm going to write this down. Each element in my domain points to only, or better yet, let me write this word. Points to exactly one element in my range. I have a function. And that's great. So in other words, if you came to me and I don't know, for some reason you were like, okay, Mr. Float, with this set of ordered pairs, I'm going to give you an X value. And you gave me the number 2. I can instantly look back at you and say 4 because 2 goes to 4. I don't know how it goes to 4 yet. No idea. But what I do know is they're related. And if you came back to me and you said, if you said, hey, -1, I would say -2 because I know that's what it maps into. I don't have to know how it maps into it. I just know that's where it goes. Okay. So we would consider this scenario on the board right now a function. So let me give you an example of something that is not a function. Okay. So here's an example that is not a function. So let's see, 9, -3, 4, -2, 1, -1, 0, 0, 1, 1, 4, 2, 9, 3. Okay, once again, I will do the same exact thing. Here's my domain. Oops, supposed to be letter D. Here's my domain. Here's going to be my range. And I'm just going to look at all my X values and just write them out. So I'll write them in red. Let's see here. We got 9, 4, 1, 0, 1, but I already wrote a 1. 4, I already wrote a 4, and 9, I already wrote a 9. So my X values are 9, 4, 1, and 0. If the numbers repeat like this 9 and this 9, all you have to do is just write it down once because you already have it. It's inside of the domain. It is one of the X values. Now let's go ahead. Let's look at all the Y values. I'll write them in this blue color. So we have -3, -2. We have -1, 0, +1, 2, and 3. And let's see. I will use a different color pencil this time. I'll use green. I like green. And reading from left to right, and I'm starting all the way up here. Starting all the way up here, upper left-hand corner of your screen. I'm just going to go ahead and draw my arrows. 9 goes to -3. 4 goes to -2. 1 goes to -1. 0 goes to +1. Oh, sorry. 0 goes to 0. My bad. All right. 1 goes to +1. 4 goes to -2. I'm sorry, +2. 4 goes to +2. And 9 goes to 3. Now, this is not a function. All right? And here is why. First, for the value of 9, notice how it points to 3, or I'm sorry, -3, but it also points to +3 as well. And remember the definition. I'm going to zoom out and scroll up just a little bit. At the top of the screen, each element in my domain points to exactly one element in my range. Well, in this scenario, right here on the board, I completely violate that definition. That 9 points to two values in my range, and I wanted to point to exactly one. So as soon as I see that number 9 pointing to two of them, boom, stop what you're doing, not a function, move on to the next question. However, if you look at 4 in the domain and you look at 1, we also violated all over again. So this is definitely not a function whatsoever. All right. And if you think about it, if you think about what I did earlier when I said, well, in the previous problem, if I said, what was the number here? If I said 3, then you would say 6. Like you could tell me exactly what it equals. Well, in this scenario, if I said, hey, 9, what are you going to say? -3 or 3? How do you know which one's correct? If you say 3, then I'm going to go, okay, well, why didn't you choose -3 then? Do you see how we get confused? Do you see how there's like that gray area? That can't happen with functions. It either is a function or it is not a function. Nothing in between. Now, this is all good. It can be a little confusing at times because we got arrows going all over the place. We have numbers and ordered pairs and everything. Sometimes a picture is so much better than just all this writing on the board. All right. So let me go ahead. I'm going to show you a website that I want you to use. All right. It's very, very easy. Many of you probably already know about this website. It is called desmos.com. All right. So desmos.com. And what's nice about Desmos is that you can type in your math exactly the way it looks on your homework or on the book. So, for example, we want to determine whether or not the following equations are functions. All right. So the first one is going to be 4x plus y equals -3. Now, what I'm going to do for us, all right, is I'm just going to go ahead and take a screenshot of this and just drag this into our notes here. That way it looks a lot better. And I can draw on it and you can see what I'm talking about and everything and all that good stuff. All right, so here we are right here. So is this a function? Is 4x plus y equals -3 a function? All right, well, if you look at it, I have a bunch of ordered pairs. In fact, to be honest with you, if you look at the red line here, I have an infinite number of ordered pairs because I can keep zooming in and keep getting more accurate and more precise ordered pairs. But there's an easier way to do this. And we call this the vertical line test. All right. And what the vertical line test tells us is that if I can draw a vertical line and hit my function exactly once, or better yet, if I can draw a vertical line and I hit my graph only once, I have a function. And if I can do this multiple times throughout this entire line, like here or all the way down here, notice every time I draw this vertical line, I only hit the graph once. So the vertical line test tells us that if you hit it once, you have a function. And there is a very mathy definition for us, all right? And I'm just going to go ahead and I'm going to kind of condense it for us here, all right? So if you draw a vertical line and touch the graph only once, you have a function. All right? Now, I think in this case, with this specific definition, I think it's a lot easier to understand it if you see one of these graphs where it's not a function, where it fails. All right? Because then you can really go, oh, okay, I see it. And I can also relate this back to the previous example as well. All right? So let's go back to Desmos real fast. And let's go ahead and let's type this in. All right? So I'm going to use x plus y to the second equals 1. So let me go ahead and copy and paste this into our notes. There we go. And I'm going to ask the question, is this a function? All right. Now remember, vertical line test. You could draw a vertical line, and if you hit the graph once, it is a function. If you hit it any more than one time, it's not a function. And look right here. I'm just going to draw this right here because this one's actually very special. So here's my vertical line right here. And notice I hit my graph here at 0.1, and I hit here at 0.2. Because I hit twice, not a function. All right. And this is what I'm saying back in the previous example. If we look at these two ordered pairs, all right, the first ordered pair, 0.1, is x equals -3, comma, y equals 2. And then the second ordered pair is x equals -3, comma, y equals -2. That is the same exact thing as saying, okay, well, here's my domain, -3. Here's my range, 2 and -2. And notice that that -3 points to two completely different y values. It's only supposed to point to one. So here is an example here where, like I said, we do not have a function. And now hopefully you can see how this works when I use a picture or if I choose to use ordered pairs. Remember, the domain value can only point to exactly one y value. That's it. All right. So now we're going to turn our attention over to finding values of functions. All right. And this isn't as bad as what some people make it out to be. Oh, remember the website? Might as well write this down. www.desmos.com. It's free. You can download it onto your tablet or onto your phone. There are apps. They're free. Everything is free. All right. Other than WebAssign, I'll never ask you to spend any other money. Okay. So function notation. Many of you have probably seen this before. But function notation has this form right here. So for the function, y equals this stuff right here. All right. What we say is this is read as f of x or f at x. Okay. And this is going to be what we call all of the range values that we can take on. And it's so much easier if I just show you like a small little example here. Okay. So here are three ordered pairs. 1, 3. Oops. 2, 4. And 3, 5. Okay. Now, earlier, we would go ahead and we would say, well, this is our domain, and this is our range. Okay? But now we're going to be even more specific with what we're saying. If you went back and you looked at the announcement for this week, I used some words like independent and dependent variables. All right? Our domain are going to be the independent variables. All right. This is something that we cannot control. An excellent example of a variable that we can never control is time. Time always moves forward. It never goes back, and we cannot change it. Time is time. So in this example, my independent variables are going to be 1, 2, and 3. Or better yet, my independent values, I think is a better way to say it. 1, 2, and 3. Now, the range are going to be our dependent values, okay? And I'm going to make this up. This is the one I used the announcements, but this would be like your paycheck, okay? In other words, if you worked 1 hour, you will make $3. If you worked 2 hours, you would make $4. And if you worked 3 hours, you would make $5. And then you would probably quit because this is the worst paying job in the history of life. All right. However, you get the point. The fact of the matter is, your paycheck is dependent. So, our paycheck is dependent upon how much we actually work, how much time we put in. Okay. And the goal of life and the whole reason why you're in school right now is so you can work as little as possible and make as much money as you can. So that's the game, right? That's the game we're playing here. All right. So let me just recap real quick. Independent variables or independent values, domain. Dependent values, range. All right. Now, how does this relate back to our function notation? Well, within the function notation, we might have an example that looks something like this. We might say evaluate f of x equals 2x to the second plus 3x minus 1. All right. And this looks entirely different from something that maybe you've seen before. Or maybe you've seen this and it's like, oh, I remember seeing this, but maybe now that I know the definitions of these things, it makes more sense. All right. So here's what's happening here. This letter x right there inside of my function notation are going to be the domain values. In other words, they're going to be the independent, forgot a word or letter, independent values that we want to explore. Okay? So whatever that happens to be, whatever that number is, because it could be a number, like for example here, I'm going to go ahead and erase some stuff. Let's say instead of writing an x, I put a 2 there. Well, what that means is my domain, my independent values are going to be 2. So wherever I see an x on the right-hand side, I'm going to replace it with parentheses first. And then I take that number 2 and I substitute it in. And I just simplify the right-hand side only. See, a lot of the times when you were solving equations, you were working on the left side, you were working on the right side, you had to move things around. Functions, you don't have to do any of that. Functions are, give me an independent value. I'm going to take that and substitute it in. And I'm going to tell you what it equals. So let's see here. 2 to the second is 4 times 2 is 8 plus 6 minus 1. And the way that we write this is f of 2 is going to equal 13. All right. Here's what is actually happening now. This would be the scenario is like if you walked up to me and you said, hey, the independent value is 2, then I would look back at you and say the dependent variable is 13. In other words, what we just found is the ordered pair 2, 13. Yes, these are ordered pairs that you can graph. So remember that x component is going to be your domain. That y component is going to be your range. And if you take that one step further, the x component is also going to be independent. Can't spell today. Independent. Yes, and your y value is going to be your dependent values. And what the function does is it relates these things together. It relates all of these together. That's exactly what we're talking about here. Sometimes people present this as like a function calculator. All right. So let me explain. A function calculator. So here's our calculator right here. We'll name it f of x. And it only knows how to do one thing. It only knows how to do this. It knows how to do 3 times something raised to the second power minus 2 times something plus 1. That's the only thing it knows how to do. So if you came into this calculator and you typed in 0, then what the calculator does, and you can't see this because it does this within like the calculator CPU and all that stuff, is it substitutes zeros in there, it crunches the numbers, and it spits out positive 1. So the ordered pair that you just found was 0, 1. Then if you came back into this calculator And let's say you typed in 4, okay? Then it's going to put 4s down in here in these spaces. 4 to the second is 16. 16 times 3 is 48, minus 8 plus 1. So let's see, 48 minus 8 is 40, plus 1 is 41. So you just found the ordered pair, 4 comma 41. In other words, and this is another way that we can describe functions, and I'm going to use a different color here. We'll use purple. You have your input, then you have your output. Your input will be independent. Notice they both start with the letter I. Your output will be dependent. I know all these definitions now are being thrown at you, and you have to know them. All right? Your input is independent. It is also your domain. Your output is dependent. It is also your range. And then your input are X values and your output are Y values. And every single ordered pair is X comma Y. That's why it's called an ordered pair. Order, X comes first, Y comes second. Domain comes first, range comes second. Independent comes first, dependent comes second. Input comes first, output comes second, and they always exist as pairs. So hopefully now you're kind of grasping on to like what I'm saying here. And sometimes, going back to our calculator here, oops, didn't want to erase that much. Sometimes in our calculator, our function calculator, I'm just going to erase everything here. Instead of numbers, you could get even crazier. Instead of numbers, you could put in letters. Like you typed in the value A. A will come down. It goes into our calculator. And since we don't know what A is, the output will be 3A to the second minus 2A plus 1. And how do we write that ordered pair? Remember, input first, output second. And that is your ordered pair. So you could come in and say, well, A can be anything I want it to be, and you can easily find that very quickly. All right? So don't let this confuse you, okay? Let's try another example here where things can get a little bit crazier, but we're gonna use a simpler function here. All right? So here we're gonna evaluate. We'll name this something different. We'll name it g of x this time. And we'll say g of x equals 3x minus 5 for part A. Let's do g of h to the second. Part B, let's do g of x plus 2. Part C, we'll do g of negative 3. All right? So here are the 3 examples I have just using this function. I'll do the first one. I'll do the first one both ways. I'll do it visually and then algebraically. So visually, here's what's happening. We have our calculator. We'll name it g of x. It only knows how to do this. You type in h to the second. H to the second goes into this little spot, and the calculator spits out 3h to the second minus 5 because there's nothing you can do there. So g of h to the second is equal to 3h to the second minus 5. All right, so that's part A. Now, the other way you could have done this, and this is the way that like books show it, and I think the book kind of takes for granted that you like completely understand all the notation and everything. The way that the book shows it, it'll say g of h to the second equals 3x minus 5. And what you have to do is you have to make the connection that you are going to erase the x, you're going to substitute h to the second, and then you're going to simplify it. And that's how we get this, okay? I think the visual representation is much better to use initially while you're learning. And then once you get better at this, you can start to see how everything kind of fits together. All right, so there is part A. Part B, g of, what was it again? X plus 2? All right, was it x plus 2? Yeah. All right, so I'll do this again both ways because I think it's so much more benefit or so much more. Oh, geez, it's more beneficial to us. To I can't even speak right now. It is more beneficial to us to have a visual representation. So here's my calculator. It's called g of x. It only knows how to do 3 times something plus 5. In this scenario, you are typing in x plus 2. The x plus 2 comes down into here. And then it'll output 3x plus 6 plus 5, which is 3x plus 11. Yes, the calculator knows how to distribute. And that's exactly what it would do. It would take 3 times x, 3 times 2, which is 6, and then would combine like terms. 6 plus 5 is 11. All right. Finally, for part C, another nice visual representation. You typed in -3, I think, right? Yep, -3. Oh, let me use a red marker. Keep it consistent. So -3 would come down into that spot. 3 times -3 is -9 plus 5. The output would be -4. And that's all we're asking you to do. We're giving you an input. You got to tell me what the output is. And that's going to be it for this video. So I will see you in the next one where we talk about visual representations of all this stuff. And it's very straightforward. Um, we're going to be using Desmo, so make sure you know where to find that information. And I'll see you in the next one.